Okay, so here are solutions to the work I set the other day. Here's question 5. You were told that the probability of each value was k times that value. So this gave you a table. They need to add up to 1. So that's why k has to be 1/10. These show that questions are, one of the ways they get around the fact that we've all got these fantastic calculators, because the calculator doesn't help you with this. This is about communicating clearly, isn't it? Question 6 we'd done in the previous video. So question 7, I took the information they gave me in the probability function and put it into a table. I can't do it any other way. And I know that these have to add up to 1, so that means the two betas, that was a Greek beta, have to add up to 0.6, so that means they are both 0.3. So for part B, I was a bit lazy for part B. I just said, yeah, I've done that. Let's look above, just replace beta with 0.3, and that means that the probability of this, so you can be -1, but you can't be 2. So it's this one plus this one plus this one, 0.7. Question 8 is one of the ones I'd like you to send me your answer to. So hopefully you can be able just to send me a photo, a quick snap, and I'd like you all to do that by Monday, please. Thank you very much. Email it to, hopefully you're okay with this, mcooper@ilfracombe Academy, blah, blah, blah. And question 9, I really genuinely had to count on my fingers for this one, because I think it's really tricky working out how many numbers there are between two values sometimes. So it's a uniform distribution. That was the key word in the question, wasn't it? It was a uniform distribution. That means all the probabilities are the same. 50 numbers, so they've each got to be 1/50. And so the probability of getting 1 is 1/50. I don't know why they insist on putting decimals in the answers. There is absolutely nothing wrong with fractions. I would argue they're much, much better. Greater than or equal to 28. So that was from 28 to 50 inclusive. Now you've got to be careful. If you do 50, take away 28, you get 22. But if you actually count from 28 up to 50, that's actually 23 numbers. So the jump from 28 to 50 is 22, but there are actually 23 numbers in there. And then C was probability of this, so that's actually everything from 14 to 41 inclusive, so that's 28 numbers. So that's 28 out of 50, 0.56. Question 10 was quite a nice easy one really, wasn't it? So this was the probability of 2 and 3 added together, couldn't be 1. This is the probability of 0 and 1 added together, and you can't have a value bigger than 3 in this distribution, so that's why the probability was 0. The last question, question 13, that's the other one I'd like you to submit an answer to. So that's question 8 and question 13. Again, just a photo would be fine. I don't know if Mr. Gobber shared the video that I put together the other day, where I talk about the fact that we've got to use this time well, and people who are not engaging during this period, we're unlikely to be able to carry on with full A level for you. So, please make sure you're making good use of this time. And if there are any technological reasons why you can't engage, we're really, really happy to talk about finding a solution to those problems for you. Okay, so I said we'd push it on a bit today, and what I'm going to do is set you up with a little sort of teaser, if you like, for what we're going to do next week. So next week, Thursday and Friday, I am going to set you some more work along these lines. And here's the thing, I'm quite good at table tennis, all right? So let's say that I decide to take one of you on at table tennis. I don't know if I've got a volunteer. All right, Kieran, you're volunteering. Okay, so let's say I play Kieran at table tennis, and I'm quite good. So let's say from my point of view, the probability that I win is 0.7. Okay, now I don't know if Kieran's got a table tennis table in his basement or something like that. Maybe I don't know. But there we are. Let's say that 7 out of 10 games I'm likely to win. We don't know how we've worked that out. There we go. And let's say that we play 5 games of table tennis. Okay. And I want X to be the number of games I win. Hopefully you can see that X is a discrete random variable. Okay, the possible values of X are: I might win no games, I might win 1 of the games, 2 of the games, 3 of the games, 4 of the games, or 5 of the games. So we could set up a probability distribution for those different outcomes. And I'd like to start trying to fill in that probability distribution. So let's work out the probability that I win no games. So that means the first game I lose. Probability I lose, 0.3. The second game I lose. The third game I lose. The fourth game I lose. The fifth game I lose. Are you happy that that's what you get? 0.3 times 0.3 times 0.3 times 0.3 times 0.3. Okay. Let's work out the probability that I win every game. So I win the first game, I win the second game. Are we happy that that's that probability? Now, filling in the other ones, that's the tricky bit. And that's what we're going to actually come to next week. But here's a start for you. Let's try and work out the probability that I win 1 game. Okay, so probability I win 1 game, well, surely it's this, isn't it? I win 1 game, and then I lose, and then I lose, and then I lose, and then I lose. So what we're saying there is 0.7 times 0.3 to the power of 4. Now, I have to tell you that that is not the answer to what's the probability I win 1 of the games. Now, I'm not completely wrong. I'm on the right lines, but I have forgotten something here. So this is correct, and this is correct, but this is not yet correct. And understanding why it's not yet correct helps us unlock the answers to the other problems. And I think it'd be worth you just having a think about that. You may even want to email me your thoughts on why this isn't the correct answer to what's the probability I win 1 game. And then next Thursday, we'll reveal all and look at this next step. Wish you all the best. Take care. Sorry, me again. Just watched this back and I realised that I hadn't put to the power of 5 there. So I'd written it correctly here, but I'd written it incorrectly there. Hope that didn't confuse you too much. All the best.